Bacteria are single-celled organisms that reproduce by splitting in half. So if you start with 1, after a few hours it will split, leaving you with 2. Then they'll split, leaving you with 4, then 8, and so on. Or maybe you have a radioactive isotope that decays in such a way that half the sample breaks down every hour. So if you start with 8 grams, after an hour you'll have 4, and then 2, and then 1, and so on. These lists are both examples of sequences. They're lists of numbers defined by a pattern. In the first case, each value is twice the previous one, and in the second, each value is half of it. Sequences, technically functions whose domain is the integers, are a useful tool for modeling processes like populations that change at discrete intervals, and they can also be used to model continuous processes like our radioactive decay, where we're only interested in the values at discrete intervals. To go along with this new modeling tool, we're also going to get a new proof technique called mathematical induction that's uniquely suited to proving things about things that change in a discrete way, like finding the sum of the values of a sequence, or comparing the size of two expressions whose domain is just the integers, and even answering questions about geometric objects, like which ones can tile a plane and which ones can't. All right, this method, as we'll see, is based on the idea that if you can make it to the first rung of a ladder, and you can show that reaching one rung of a ladder, call it rung n, always implies that you can reach the next rung, call it rung n plus 1, then implicitly you can get to every rung. So where to begin? Well, first we're going to need some definitions. Then we'll look at some examples. These definitions usually get clearer if we can make them more concrete with some specific examples. Then we'll look at our new proof technique and see how it applies to a variety of different fields. And finally, we'll wrap up with a look at some of the ways sequences can be used to model practical situations.